Okay, so welcome to the new series of seminar of our institute. We are happy to start with this new season of seminar with one of our best researchers, Giovanni Cerulli, that will present optimal policy learning from the policymaking perspective. As I said before, I just want to ask you to switch off the microphone and to wait until the end of the presentation for questions to the author. Please, Giovanni.
Thank you very much, Lucio, and thank you for all the people attending this seminar. And I'm very happy to deliver this seminar, and I hope it will be useful for you all. This seminar is about policy learning and is, of course, a very hot topic. And it's also a bit different from the kind of approaches on policy analysis that are generally analyzed and carried out in a practical empirical analysis. Because it is much more about ex-ante analysis than ex-post analysis, and so it means that we are much more focused on trying to come up with a selection rule able to identify the best individual to treat. So we can rephrase in some sense this presentation in terms of I would say optimal policy assignment from the policymaker perspective. Okay, let me start with some definitions that are important at this in this case. First of all, what is policy learning in this context? So this is not, of course, a general definition. This is the definition that I need here for going ahead in this seminar. I define policy learning in this context as the process of improving program welfare achievements by reiterating similar policies over time. So the main idea is that as long as we're going to have different rounds of similar policy or the same policy, we would like to come up with an increase in knowledge and ability to select individuals to maximize the effect of the policy, whatever this effect is intended to be. What is optimal treatment assignment, which is a very central point here, is the idea that the policymaker can be able to optimally fine-tuning the treatment assignment of a prospective policy. So we are in an ex-ante perspective, by using previous results from a randomized control trial, for example, or from an observational study. So, in other words, from other policy that have been implemented in the past. And of course, it depends on the assignment rules. On the assignment rules we are dealing with, and so we have to identify specific classes of policy over which we can get a possible result. And I will focus on threshold-based policies. Threshold-based policies are really relevant because they are very simple and conceptually and very used in practice, as I'm going to show you. The main idea is that we are going to generate some cutoffs and assign individual to treatment or to policy to policy implementation using exactly this cutoffs. Another third fundamental element is the concept of maximization of the welfare. Sometimes we speak about effect of a policy, sometimes, and even more precisely, we should speak about the welfare effect of the policy, which is an improving of the social welfare function in some sense that is behind the policies that we are, the policymaker is carrying out. However, the policymaker very hardly managed to reach the best solution of a policy, which means that an unconstrained maximum welfare, and because of institutional economic constraints, sorry, contains, but it's constraints of various sort. So it means that we need to understand how to deal with the problem of not be able to achieve the maximum welfare possible. This is the classical situation, and I will provide a possible solution, which is also a technical solution and I would say a policy solution, that is that of providing the policymaker with a menu of possible choices in the assignment rule. Okay, let me start with, okay, I would say that this presentation might be a bit technical, but I'm sure that the main points will be quite clear. Okay, I push you to think about the policy as a selection problem in this case. Of course, the policy is a much wider concept. So in this case, we are more technically speaking about policy as a selection problem. So on the one hand, we have at the very beginning, at the very start of this scheme, we had the policy objectives and policy constraints. Okay. Policy objectives may be of any sort. For example, they may be increasing employment or allowing women to, for example, set up a company, or microcredit interventions, whatever you want, okay, or policy for R&D, patents, whatever you want. And of course, there are many constraints. For example, a typical constraint may be we want to help just small firms. But the problem is how to define small. How can we say that a company is small, which is the threshold to identify the optimal level of this let me pass the expression smallness. And on the other end, we have the policymaker action. When the objectives and constraints has been determined, the policymaker action is the hand of is the paternalistic hand of the society that is going to select what? Select cherry picking. In this case, is apple picking, I would say. The best units, the units that are able to maximize some welfare function or a index, right? So the main idea is that there is the selection of the unit, and among all the available options, there will be a choice, a specific choice from the point of view of the policymaker. Okay, this is the simplest slide, and then we are going to become a bit more technical, but I hope that you can understand all the steps. As you can see, technicals are also the journals in which this theory have been developed. Chalmatsky is, of course, a super name, a big name in this field. I would say the most important probably worldwide about policy making, choice, and assignment rules. And I suggest to read this wonderful paper. But also very recently, we have had a bit more interest in developing, I would say, a feasible approach to transform what is theory into something that can become treatable and feasible in practice, right? So this is probably the main reference for the paper I am going to show to display now. And the main idea for me was to take many of the insights into this paper and transform them into something more manageable for standard people and policymakers to apply. Okay, it doesn't mean that it is simpler than these papers, but of course I try to make it easier also to understand, because this paper are very technical and sometimes hard to be clearly understood from the layman. Okay, from the layman point of view. Okay, the starting point is the policy learning within the policy evaluation cycle. This is a project funding system, which is very known to everybody. Suppose that you are considering a PhD program and there is a prospective individual that would like to attend this, to be enrolled into the PhD program. At the very beginning, there is the unit eligibility. The individual may or may not be eligible for the program. For example, without a master degree, it's not possible to get into a PhD program, right? So if the eligibility is yes, we are going to consider the individual is going to consider the second step. The unit may or may not self-select itself and or herself. And when no is the response, well, we have a non-eligible unit that is part of the potential counterfactual pool of individuals that are not treated, of course. So they are the not treated or not selected individuals. So if you want to come back, they are the green apples, right? And then we have the self-selection process. The self-selection process may be, yes, I am eligible and I would like to apply for a position, right? So it's a yes. But if I say, oh, I am eligible, but I don't want to apply, so I will be part of the non-applying units, and so I will be here, right? Then in step 3, this is the agency choice about individual. The agency's choice, for example, at university level, or maybe a committee that is going to decide whether or not to select this individual. And this agency unit may have many different objectives, right? For example, they would like to increase the level of, let's say, of people more engaged in for example, I don't know, for higher math abilities, or they would like to, for example, to select individual having having some experience in, for example, I don't know, a certain kind of studies, a certain kind of knowledge, and so on. So the agency may have different constraints, also budget constraints, and on the other hand, different objectives to achieve, right? So on the basis of this, the committee is going to select someone or is going to reject some of the applications. And when the applications are rejected, we have the non-supported applyee units, but they were applying, so they were trying to be part of the program. And so we have the agency implementation, which is when the policy is actually carried out. And we know very well about the fact that this is an itinerary evaluation process. The previous one is an ex ante evaluation, in the sense that we are in the selection process. Then we have the itinerary evaluation, which is about evaluation of the process of selection. Then we have units behaviors. So finally, these students that will be enrolled inside are going to do something. For example, they're going to attend courses, they're going to pass some exams, and so on. So at the very end, we would like to measure the effect of this by a final exam, or we would like to see what was the placement of this individual within the job market, for example, in terms of salaries, in terms of position, or whatever. In this case, we are in an ex post evaluation setting, in which we would like to compare what is going on with them that attended the course, that were enrolled into the program, and compare them to those that didn't receive the treatment, that didn't get the support, that was basically not under enrollment. Okay, this is the main idea. And here we have the ex post evaluation. But there is this is the point in which step 7 is extremely important. Generally, at least in my case, for example, I wrote an entire book about this part, how to come up with the good measures about the ex post evaluation. But for example, this part in the literature is really missing. And what is this part? It's step 7, using the ex post evaluation, what we have learned from past experience in order to increase the ability to select an individual in a proper way, with the end of increasing the welfare, increasing the ability, for example, to select individual able to do well in the job market, and so on. So this is the process that we are going to follow according to pre-specified criteria, okay? So I will speak about how to do this based on the experience on that. Okay. But now it is very important to understand what we mean when we speak about the effect of a policy. This is a very big problem, and if we have definitions, I would say mathematical simple definitions, we can go ahead quite smoothly. Okay, what is a total policy effect? Call gamma the gamma S, and then I'm going to explain what S is, because it's a function of S, the total effect of a policy. This may be a total effect on all individuals or on the average individual, okay? That's not important for us. What is important is that this is the concept of, a global effect of the policy. Well, in a policy that is made of a selection process, and we say that whatever policy has a selection process side, we can split the effect into 2 components. The direct effect alpha, so which is not depending on S, and another part beta, which is the indirect effect that depends on S. What is S? S is the selection process operated by a specific policy treatment rule. So in other words, it is the selection, is the effect due to the selection process operated by the individual. And what is the direct effect alpha? The direct effect alpha is the effect that we get, is the effect obtained if the assignment to treatment, the assignment to the support was run at random. So in other words, without any specific objectives. So is the pure effect of the policy independently of the effect operated by the selection. So the main point is that if we define this in this way, we can speak about the empirical welfare maximization as a process to maximize the indirect effect, because this is not depends on us. This depends on the characteristics of this does not depend on the selection. Okay, this is depend just on the nature of the policy, but not about the selection that we operate. And we would like to generate an optimal assignment of the policy within specific classes of policy, because of course we may design a large amount of different policy that can be used exactly for this aim. So if we have clear in mind exactly that there's a split between the direct effect and the indirect effect, we can go ahead quite smoothly. Okay, having said that, now I'm going to be a bit more technical by exactly explain how can we exploit S, so the selection process, the treatment rule, to increase the welfare. And in this case, I need some further definition about what is a selection process. Well, a selection process, G, as you see, is a mapping. What does it mean, a mapping? It's a process that link in one direction the characteristics of the individuals with a variable 0, 1, which is binary, which is 0 is not selected, 1 is selected. So given my characteristics, for example, I might have a certain age, a certain education, or a certain social status, and whatever you want. And given my characteristics, I will be assigned by the real J to 0 or to 1. If I am a 0, I will be untreated or unsupported. And if I get a 1, I will be supported. So is a G the rule that I'm looking for in some sense, right? Okay, we can also define the effect of the policy that we are going to measure by a counterfactual approach. For example, and we define the effect of the policy, the general effect, as a tau x, which depends on the characteristics of the individual. And this is a counterfactual measure, because this is the average effect on, for example, suppose that I'm speaking about myself, right? This is the expected outcome of myself when I am treated. Myself depends on my characteristics x's, minus the expected outcome of myself when I am untreated. Okay, so this effect is measured over G, over myself, over every other people. Okay, so everybody has a specific tau x. Lucio has a specific tau x, and Serena another tau x. Everybody has his own tau x, depends on his characteristics. If the individual are exactly equal, the same people, well, the same person, sorry, in this case, the tau x will be the same for everybody. If we are going to take the average over all the individuals, okay, we get the average effect of the policy, which is tau. Tau is the average effect of the policy. That is a way to sum up the policy, the effect of the policy over the different individuals characterized by a specific bundle of X. Remember, X may be age, education, family of origin, location in where individual lives in, whatever you want, okay? It's just a bundle of characteristics. So tau x, of course, is not identified, but we can identify this under certain conditions that but before identifying this, suppose that for some way we know tau x for each individual. So it is possible with so my book, for example, is exactly about how to estimate this, but all the program evaluation is about how to estimate this guy, right? So suppose that we have a good estimate of tau x. So I know the effect of the policy for each individual characterized by a vector x. Well, having said that, this tau becomes a tau hat. Hat indicates just that it's an estimate, right? So something that we have estimated from the data, So we can define the actual total effect of welfare as exactly what? As the sum of the over all the individuals of the effect of these of the treated individuals. So in other words, Ti, that was exactly Ti, is a 1 or 0, right? Well, it will be positive. So we are measuring here the effect on the treated, basically, because they are those that were selected. So just for the selected, I have a final welfare that is measurable because it's the effect of the policy in the actual way. Okay, and this is the welfare. And however, the point is, this is the welfare that we get from running this policy. But there is another point which is extremely important. Is, okay, I run this policy in a certain way, but is there a way to define an unconstrained maximum welfare that I could have been able to achieve some way? Yes, and it is this maximum welfare, or W star hat estimated. It takes exactly the same argument, except that instead of using the selection rule 0-1 that I used, that the policymaker used, we use a special kind of assignment to treatment, which is the one of taking just those having a positive tau. So if we consider to treat just those that have a positive effect, we are maximizing the treatment. And this is a sort of first best of the policy, in which we are just selecting those that do well. They do well in terms of a positive effect, right? So this is the maximal achievable achievable welfare in this case, given, of course, an individuals. Well, the point is that I can define the regret. The regret is defined as the difference between the maximum welfare achievable in this population, or let me pass in this sample, minus the one that I achieved using my policy rule. So, and the main idea is that the regret is generally positive, meaning that I was unable to reach the maximum level of welfare possible. Okay, I know that it's not very easy to understand. So I generate an example, simulated, it's very easy. And so from this example, you can better understand what I mean. This is an example of an optimal policy assignment rule, and I calculate the regret for this policy, okay, which is 16. Okay, suppose that I run a policy over 6 individuals, and the policymaker finally came up with 3 treated and 4 untreated. Okay, so Mr. 1, Mr. 2, and Mr. 3 are treated, have been selected according to the policymaker objectives, and other 3 people, Mr. 4, Mr. 5, and Mr. 6, were untreated, 0, 0, and 0. So this is the treatment rule decided by the policymaker. The policymaker came up with this distribution of treated and untreated. Okay, so suppose that for some reason we were able to to define the effect for each individual. So this is the conditional average treatment effect. For example, Mr. 1, suppose that as long it is positive and higher, this is a good effect. So this may be, for example, earnings. Okay, so if I see that this one is larger than 1, is better. Okay, that's the main idea. So is a monotonic positive welfare. So the main idea is that Mr. 1 was particularly doing well, because among all the 6 people, it is the one that got the highest level of the impact or the effect. Mr. 2 was not bad, it was negative, minus 4, was even detrimental for him, this policy, because here we already have a counterfactor, right? Remember the definition. And Mr. 4 was good, Mr. 6 was good, and Mr. 5 was not really good. Okay, now I'm going to calculate the welfare achieved for this policy, the one that I got from this policy. I just multiply t by tau, as you remember, and then I sum up. Of course, what I get is 10, because it's now minus 4 plus 5, right? So this is exactly what you have seen here. Okay, this is this one. Okay, so this is the actual welfare. Now, suppose that I apply the optimal unconstrained welfare. This is this one with T star. What is T star in this case? Well, I have to select just those having a positive tau. How many are they? 1, this one, this one, and this one, right? And then also this one. So in the policy, I was selecting those having a positive effect. So 1, 2, 3, and 4. Now I'm going to sum them up, okay, multiplying tau by tau star, and I see that the maximum welfare in this case would have been 26. So if I had treated this one, this one, this one, and this one, and not treated the other guys, this one and this one, well, I would have been able to achieve a welfare of 26 against 10. So my regret is 16, which is quite sizable in this case. Okay, so the main idea is that another policy rule would have been able to generate a larger welfare, but I didn't exploit this for many reasons. For example, because I had a lot of constraints. For example, this individual cannot be Mr. 4. Might be one guy that should not be selected for some reason, okay? Because, for example, he has a peculiar X or age or education that is not part of my policy objectives. So the main point, and I go ahead, is that eligibility, budget, ethical, or institutional constraints does not make the policymaker able to implement the optimal unconstrained policy assignment. So this is a level of the maximum welfare very hardly achievable in the reality. Okay, so they are obliged we are obliged so policymakers are obliged to rely on a constraint assignment rule, selecting treated according to specific characteristics that of course comply with these constraints. And generally, if we do that, the level of the welfare drops down. So generally, we don't have exactly 26. In fact, in this case, we have 10. So this is a classical example in which we have a reduction in the welfare that might have been achievable. And the policymaker would like, however, to produce the largest feasible constrained welfare. So this is a point at stake here. And this is what I want to show you here, that among the many possible constraint policy, we would like to cherry pick in the best. In other words, we are not sure that this is the best policy possible, achievable, even under the constraints that we have. So the main idea is, let's try to find a policy that is the best possible at T, which is of course not equal to T star, because T star probably is not possible to be implemented because of the constraints, but something that can be closer to this point. Okay, the problem here is that we have a large number of policy that we can analyze. So it is not possible to define a simple rule for come up with a best constraint policy. The very problem is that we have a lot of policy that may depend on X, on the characteristics of the individuals, and so we have to consider the classes of policy we want to work with, and this depends on the context. In this presentation, I will focus on threshold-based policy. Why? Because the threshold-based policy are very, very intuitive, largely used in applications, and especially by policymakers. What is the threshold-based policy? It's very simple. If you, for example, open up a whatever document, policy document in whatever field, you see that when there are threshold policy, you see that, for example, all individual complying with certain thresholds, overcoming some certain thresholds can participate are eligible for the policy and can be treated within the policy. For example, only companies with more than, let's say, 20 employees can access this kind of support. Or, for example, only people with an age larger than a certain number of years can participate to this, possibly to this policy, and blah, blah, blah. And then we may have also not just one single threshold, but we may have many thresholds according to different kind of selection criteria, okay? So, and this is one of the possibilities. So now I will focus on threshold-based policy, okay? Threshold-based policy. Okay, and this is exactly the policy rule of a threshold-based policy. Okay, this is the constraint depends on the fact that we are using exactly a threshold. So what we can do is to define, first of all, look, the optimal unconstrained welfare. So this is the optimal treatment without the constraint, and then we have to introduce the constraint. The constraints, look, this is a unit function, which is takes value 1 anytime what is in the, when the argument is true. So it means that as long as X is larger than a certain threshold, okay, this becomes a 1, otherwise it's a 0. And so an individual having characteristics X will be selected only if his X or her X is larger than a threshold that we have to fix beforehand. So it's very simple conceptually. So the main idea is that, suppose myself, right, Gio, okay, you have Gio as, for example, 47 years, right? So this is my age. So I have the, that if my age is larger than a certain threshold, right? For example, if it's larger than 35, Gio is possibly selected, and it gets a 1. And so this is the optimal policy, which is equal to, of course, Gio will be selected if it gets a 1 here and a 1 here. So as to be the one having a positive effect, and at the same time complying with the rule we have set up. Okay, so this is the main idea. There is a big question here, that first of all we have to decide which X to use, and the second point is to establish which is the threshold. So in other words, if I want to maximize if I want to maximize the welfare according to this rule, it is clear that this welfare depends on the X and depends given X to the level of the threshold that has been selected. Okay, now define the welfare, the constrained welfare. Now the welfare is nothing but the product for each individual of this. So this decision rule is for one single individual. So this is a decision rule to decide whether Mr. I can or cannot be selected, right? Then I'm going to sum up exactly all this. And if I'm going to sum up all this, okay, and multiplying by the effect that we exactly have the welfare, the final welfare of the policy. A welfare that now it depends on two elements that are unknown: X, so which variable I want to use for selecting, and the threshold to select. This is extremely important. Okay, now the main idea is that X may be fixed beforehand, for example, education, age, whatever you want. The very point is how to choose the threshold. And this is an empirical analysis, very, and can be used using a greedy approach. What is a greedy approach? Generating a grid of a possible threshold, and then selecting the threshold that maximize this argument, okay? That maximize this function, this objective function. So the main idea is that if a threshold star exists that maximize this, well, if it exists, we can identify the maximum level of the constrained welfare exactly at this threshold. This is the threshold that maximize this unconstrained welfare. And this will be the best threshold possible, okay? So the one that is able to allow the policymaker to achieve the maximum level of the effect of the policy, given the constraint introduced in terms of the X chosen, but more importantly about the threshold chosen, okay? Okay. What happens if we have more than one criterion? So far, in this case, I just consider one single X. So in a multivariate case, let me pass this expression, there is no a big difference. Instead of having just one X, we have another variable, which is Z, okay? And there is no problem because the selection rule now depends on two thresholds, the threshold for the variable X and the threshold for the variable Z, and then we have just to multiply. So it is a multiplication of three components, right? And these are the components that depends on the two thresholds. So basically, we can design, given that, a procedure, a protocol, an algorithm, depend the way which you want to define this, and how to estimate the optimal treatment assignment. And so for maximize the optimal constrained welfare. Suppose that we have we may have both randomized control trial, or we may have an observational study, okay, already done. So a policy that has been run in the past. So we have the triplet Y, X, and T, right? The effect that we observed, the characteristics on the individual, and who was or wasn't treated at the beginning, okay? So this is what we get from the previous policy, okay? And we do not know whether this T was achieved optimally or not. This is not our business. This is just what we have here, and it is our starting point. Then run a quasi-experimental method, for example, matching, or for example, regression adjustment, whatever method that is going to estimate the ex post the tau x, which is the effect of the policy for each individual. And by estimating that, compute the welfare, the actual welfare achieved, which is W hat. Well, identify, if you want, the optimal unconstrained policy. So this is the best possible solution, probably unfeasible. And then the regret, okay? The regret can be estimated here. Then consider a constrained rule, which is Tx, x this time is a vector, x1, x2, x3, and c is a vector of threshold, c1, c2, c3, ck. And given given the set of selection variable x and the related threshold, estimate the maximum constrained welfare, which is this one now. Okay, build a grid of possible threshold, and then optimize over the grid so that we can come up with the optimal policy, constrained policy, okay, welfare. Okay, I know that it's a bit, I'm going to provide an example so that you can immediately catch the logic of this, and also the problem that can come up, because everything is very smooth here, but when you go through the analysis and the real data, some problems may come up. Okay, this is the Lalande dataset, which is very famous, the National Support Work Demonstration, which was an RCT, so it was a social randomized control experiment, okay? So in other words, the treatment in this case was administered randomly. We have the effect, what we want, the target is the effect of a job training in 1976 on people real earnings in 1978, 2 years later, 2 years after attending the job training. Of course, we have treated and untreated, and we have some characteristics like for each individual: age, race, educational attainment, previous employment conditions, and also real earnings before treatment, okay? So all these are the control, the axes, the characteristics. This is the target variable, and again, this is an RCT, so it's a randomized control trial. So it's a perfect condition for us to start with, because we have a context in which we really know that the average treatment effect is just the difference in mean. So we can come up with the effect of the policy when the policy was completely random, so we can disentangle immediately the effect of the selection. Because if we run just a simple difference in mean, treated without untreated, treated minus untreated, on average, on the average earnings, we can come up with the effect of the policy void of any selection process, and so adopt the best selection process possible. Okay, I estimated this by regression adjustment, nothing really special, and this is the distribution of the tau x and tau prime, and you can see this value is 1.8, which means that on average the policy was effective when randomized, and showing that there was pretty $2,000 more per year for those that who attended the training. So in other words, the policy was in fact effective, and everybody knows this. And and in fact, more precisely, the effect is 1.76. So 1.76 means that those that attended the policy finally got $1.76 thousand more per year than those that didn't attend the training. So the training the job training was in fact able to generate an increase in the earnings, in the earnings raised in the job market on the part of those that participated to the training. Okay, that's the main point here. Okay, and this is randomized. So this effect, which is 1.76, is our reference point. So, and the main idea is that, okay, this is if you are going to run randomly this policy with no selection at all, just picking up the individuals, cherry picking individual at random. So those who are treated and those who are treated just taken at random without any specific strategy, right? So you are going to get an average welfare effect of 1.76. So the main idea, what's going on if we're going to introduce a selection process? Is there the possibility to increase the welfare even more than 1.76? And this is the very point. And here is where the methodology we have seen before comes in handy. Because in this case, we are going to, first of all, doing 3 separate univariate selection processes. In this case, I adopt the threshold-based using, as remember, the X and I go back, the X and the C. So I'm going to decide that X is, in this case, this variable, real earning is 74. So I am selecting using this selection criterion, the level of the earnings in 74, and then I have to find the optimal grid. So sorry, the optimal cutoff at which I can get the largest possible welfare. I try several different cutoffs in the algorithm, and I come up with the optimal threshold is 0.96. If an individual, if we are going to select individual according to this threshold, so all those that have a real earning in 74 larger than $0.96, it means it's $1,000. In this case, all these individuals will be treated according to this rule, and all those having a value which is smaller than this will be untreated. If I adopt this threshold, look, I maximize the welfare, and which is the welfare I get is 2.75. So compared to a non-selection process, a policy completely run at random, I get a very, very big increase, which is half of the effect of the randomized policy. 0.89 is our gain, okay, is our gain. So the average welfare gain by selecting over this variable using this threshold. Now I change the variable. Instead of selecting over the real earning in 74, I just select over age. And as you can see, if I'm going to select individuals to the policy only when they have more than 43, 42, right here, this is the threshold. So I maximize my policy in this case. So I get the maximum here, okay? And this maximum allows me to get even a larger value with 1.09 difference between the randomized case. So I do very well in this case. I do very well. Finally, I can now use education. And for the first time, you know that this is in gray. I see that there is a big problem here. Education, as a selection criteria, generate what is called a monotonicity welfare. What is monotonicity welfare? Is that if I still continue to increase education, the level of the welfare increases and increases and increases. But there is a big problem here. Look, which is the number of treated units in this case? Might be 0. Not might be, is 0. Okay, is 0. So it means that it's much better to treat because nobody has a level of education which is equal to 16 years in this data set. Because there is a monotonicity, it means that as long as you're going to increase the level of education, the welfare increases, it increases, so there is not a maximum. internal, I would say, an inner maximum. The maximum is a corner solution. So this means that the maximum is reached at the maximum level of the education. And how many people have this maximum level of education? Nobody, just one if you're lucky, right? So you cannot treat one individual out of 443 because it doesn't make sense. Okay, now before going to discuss how to solve these problems, I want just to show you an example of a policy which I introduced two constraints. Okay, one on real earning is 75 and one on age. And you see that the threshold policy identify a quadrant, which is the upper right quadrant, which is the optimal selection zone. So those that are in yellow, in orange, to be honest, are those that are to be treated and that generate the maximum welfare possible over these two criteria, age and real earning 74. Look, now we have an average welfare which is very big, is 3 times the one we get in a randomized condition. So here, selection process induces an increase in the welfare, which is really giant, and is around 4. Okay, but there is a big problem again. The share of treated is just 1%. So if you want to get a similar level of average, you should just treat the 1% of your population. It does not make sense, of course. Okay. The one you see here is not important for us. It's just the estimation of the decision boundary, but this is just for fun, not because the decision boundary is very badly estimated, because the right decision boundary is this one, and this is an approximation. That, of course, because there is big sparsity here, but that's not important technically. Now we see that we have a lot of problems when we want to maximize a constrained welfare. The first one is the monotonicity, that there are some variables that generate the monotonicity problem. It is exactly this one. For example, education has a monotonicity problem, because as long as I'm going to increase the education, I see that the welfare increases, and I cannot reach an internal optimum. So that I will finally oblige to come up with a threshold, which is a corner solution, which is not good at all, of course. And the other one is the sparsity problem. Solutions that may be inner, but that may be internal, but unfortunately, that finally selected just a few people. Or so we may have the extreme case in which, on the one hand, we might be tempted to treat everybody. On the other hand, we are tempted to treat just a few individuals. And the other point is that, of course, this is very, very nice, but might be a problem. But how to deal also with the problem of a budget that we have, because we have a budget constraint, right? So we had to come up with an idea of how to do this. Well, the solution is the menu strategy. What is the menu strategy? The menu strategy comes up anytime we have a trade-off. And in this case, we have a lot of trade-offs, because we had to decide whether to treat individuals according to specific access, specific characteristics. And we see that if we are going to use specific variables, we might have solutions that are sparse, or that are possibly unfeasible technically. Okay, I'm going to deliver you the idea of this by selecting 2 variables for analyzing the menu, which is age and education. So my axis, this is a policy, and my policy will generate the selection over 2 variables, age of individuals and education of individuals. However, in this policy, I will leave the age to be set as its optimal level. So I run first an analysis by letting age to be at its optimal level. And I'm going to vary just education. Remember, the education had the problem of monotonicity, right? So I leave it free to vary and see what is going on. And this is the final solution. As you can see, okay, start from these and then go ahead. This is the menu. It's like when you go to the restaurant, right? You have different menus and you have to choose the menu that you like more. No one is better than another, but some of them may be more problematic, okay? For example, suppose that we are here. Okay, education and age. What is, according to the rules that we have, according to the procedure we have seen before, the protocol, we come up with a situation in which the average welfare is 2.74 in this case, which is very good because it's higher than the randomized case. And the shadow treated is 47%, and the threshold for education is 3 years of education. So if you're going to treat the people having, selecting people with more than 3 years education, you are going to select 47% of the population getting this result. This is an option that might be good because at least I got, the result is quite good and also the percentage is very good. If I'm going to increase the level of education from 3 to 4, you see that the level of the treated increases, okay? So, and I see that the level of the welfare also increases as well. And then I continue and I continue in this way. So decreases, sorry, not increases, decreases the shadow treated, of course. When I increase the level of education, you see that the welfare, look here, the welfare increases accordingly. But there is a problem, and this is the trade-off. The trade-off is that I'm going to reduce the number of treated. At the very end, look here, I'm going to get the largest possible welfare, which is 4, okay, 4, but nobody's treated, just the one guy. So it's a 0.001%, okay, so it's 0. So this one, only one guy is treated. Here, just the 2% is treated. And here, just 4%. So according to the budget of the policymaker, so suppose that the policymaker has $1 million, right, €1 million, sorry, 1 million euros, okay, and has to decide how to run this policy. Well, the point is, please look at the right percentage, at the percentage of the feasible percentage of treated that you can achieve given the budget constraint you have, and then once found this, please look at the welfare you get. And in this case, for example, it might shows, for example, just an example, this one is the optimal one. For example, this is allows for a 36% of people treated. The threshold is treated just those that have 9 years and more of education. And finally, you get welfare, which is 2.92, which is quite higher than the randomized one. So it makes sense to run a policy with this kind of approach. So the problem is the policymaker can establish where locate the policy, where is the point of this menu that he wants to select according to the budget constraints or whatever, or even according to the education level, okay, also the education level. But what is important is that he knows in advance which the effect is based on the past experience. That's the point. So if the past experience is good, is made over a good amount of information, of course, the level of this measure will be more precise. And so the policymaker can say, okay, good, this is a policy that can be suitable for me because, or for the society, or for the budget we have at any level. Of course, the choice also of education and age might be very important and very central. I'm not, in this case, we can also choose the optimal, we can optimize over the axis. In other words, trying to singling out what are the axes that increase the most the effect. This is a classical machine learning problem, which is a tree-based approach, for example, that we do. In the tree-based approach, we try to find exactly not only the threshold, but first of all the variable to split. So variable to split as a first step, and second step the cutoff or splitting point. And this is the typical thing that we do when we run regression trees, for example. And the regression trees are based exactly to this. So the policy learning is very close to machine learning, because it's a selection problem, it's a classification problem, it's equivalent to classify. So conceptually, the two theories are very close to each other. So this is something which is very close to a regression tree model. Of course, because we are speaking about a threshold-based policy. Okay, in my opinion, policy learning, I go to the conclusions, is a new frontier of econometrics of program evaluation, and it is testified by the fact that we are a few working on this on the one hand, and at the same time, the papers that have dealt with this are very recently published. And of course, the policy learning approach is very old in terms of it goes back to the works by Maskey in the 90s, okay, and early of 2005, 2004. Okay, I think that theory-driven and data-driven can complement one each other, because also we need, for example, to better understand what might be the axis to consider for selection. Okay, the extension to method for estimating aiding and aiding also in unobservable selection are quite useful. We can improve the estimation of the effect to use with machine learning algorithms. This is important, but not strictly speaking the very heart of the issue. And welfare monotonicity and sparseness can be solved by the menu strategy. So I really suggest to look at the menu strategy, of course, according to the budget constraints. It will be interesting also to generalize the previous approach to other classes of policy. I just consider the threshold one, but we can consider also a linear combination of the axes. For example, a policymaker may say, okay, I have three variables, right? I give the three variables, three different weights, and then I come up with the optimal weights, and so that I can establish what are the individual that maximize this policy according to the weights given to the three variables. This is equivalent to finding the threshold. Instead of having the threshold, we have the coefficient of the linear combination to find optimally. But conceptually, is the same approach. And then providing Stata R of Python software implementation. What you have seen so far has been implemented instead by myself with a small command, but so far I just implemented this for one or two splitting criteria, not for more. So we should generalize this to 3, 4, 5, 6 different criteria to split on. And there is a paper that you can read. It's quite short. It's a 12 or 13 pages paper, because I'm very short when I write. And it's called the Optimal Policy Learning from Theory to Practice. That is basically a report of what we have seen in this presentation. I finished here, and I thank you for attending and to have listened to me. Thank you, Lucio. I leave the floor to you now.
Okay, thank you, Giovanni. Thank you for your interesting presentation. And I want just to invite the audience to make some question. Please let me know if you have some question in the chat of the Zoom chat.
Maybe they can speak or no. I don't know if they want.
I want just to avoid that more people start to speak at the same time. So
okay,
if you have some, if there is someone that has some question, please, this is the moment. Okay, No question for the. Come on, don't be shy.
Don't be shy. Don't be shy, please.
Okay. Yes, Manuela.
No, yes, I don't have questions. Thank you very much for the seminar. I find it extremely interesting. My point of view, of course, is comes from a different research field. I mean, I'm a scholar in science policy, so it's policy learning for me has a complicated type and broader type of meaning. But the model that you present and this optimal policy learning method is really interesting as a complement for the problem of policy learning. I have just elements. You point out the policy, so-called policy evaluation cycle, which is for me a bit strange because I am generally dealing with the policy cycle, which is the policy cycle is generally the decision making, the policy of design an instrument and then evaluate it and using so evaluation is a component of the policy cycle. While you are instead speaking of this policy evaluation cycle, I think this could be more elaborated. I understand that the paper is is a more technical one, let's say. But indeed, having this notion of policy evaluation cycle exposed, I think it should be more precisely determined to understand what the contribution can be within the policy cycle of the policymakers. So this is the first point. The second point is the impression that I have always when I saw this kind of contribution, that there is a very simplistic way in which you picture the policy decision-making process. And simplistic means that there is something that never is considered. For instance, the combination of the decision with about and the evaluation of one specific policy instruments, the combination of this instrument and its results and with the presence of other policy instruments which deals with the same type of intervention, maybe also dealing with the same type of recipients. This is something that I think should be considered when a system is designed, because it's the problem of policy making very, very important emerging in the last in all the fields. But this is just two about out of several kind of observation I have, but I don't want to keep more time and leave the time for other more precise questions for you. So many compliments, Giovanni, but again, I think you have to, let's say, complicate a bit the assumption of the model.
Thank you very much. Lucio, can I respond immediately or?
As you prefer.
Yes,
if you prefer to have
yes, I would prefer to reply immediately. Yes, I thank you, Manuela, for your comments and for your also congratulations, I would say. As I try to explain also in other situation, I found this new approach to policy learning interesting, and I agree with you that it's a good way to complement more policy science, the political science approach that is more qualitative, but extremely important also for modeling, because we are not able to model if we do not have a clear understanding of the process of policy. So I don't believe that there is a gap between quantity and quality. I think that they go together all the time. I completely agree with you about it. And so I come to your second point, which is the use of a simplistic model. You're right. This is a very simplistic one, which in some sense you have a policy which is also simple, characterized by one single objective, one single trick. Sorry, specifically in this case was a training, let's say. And possibly the situation in which is quite clear what are the variables to select on. You're right, it's quite a simple situation. My impression is that we don't have to take, let me pass to explain this approach like the Bible. This is a bit more a way to help the policymaker designing the future policies. Help. It doesn't mean that they are the way in which they have to design, right? So these are indications and maybe suggestions about which variables to take and see a bit of the effect, or understanding also the problem of sparsity. So the problem of I would like to do okay, myself, I would like to go to the moon, but probably I have to stay on the ground because you know that possibly we cannot achieve too much with what we are and we have. So I think that this scheme may also be used by the policymaker to understand the limits he has or the potential he has or she has. So I agree with you that the simplistic side is one limit on the one end, but maybe also an advantage, because it may also singling out immediately what is problematic in the policy the policymaker wants to run. A combination of instruments is, of course, another big problem, because you're right that the policy mix is a big issue. And of course, if we are going to complicate this scheme, of course, things are not so easy as they seem. And also, it is not easy to find two policies that are very similar over time. So I didn't have the time to speak about it, but I can interpret that you believe that this is another problem, that we are learning about the past, but it is not granted that the future or the present is one-to-one with the past. So probably we might have problems of implementing a policy which may be completely new. And in this case, we don't have information about the past. So we have just a very rough indication of what can work or what cannot work. So I agree with you that the situation are much more complex than these. This is a first step, in my opinion, to rationalize and making operational, some principle of coming from the choice theory and the statistics and the econometrics to make, in some sense, the policymaker able to be confronted with a menu in some sense in the menu. And this is my main so there is not a magic the magic number or magic solution, or there is not a one fits all here. The problem is to find a solution within a larger menu. There is a lot of uncertainty inside those.
Okay, thank you, Giovanni. We have a first question by Yamarti Rossi.
Yes, I am.
Okay.
Can you see me now?
Yeah.
Yes.
Okay, perfect. Yeah, first of all, thank you very much for your presentation. It was really insightful. And Yeah, I have two questions. One is about the evaluation cycle, and after point 6, we have 7, and we go back to point 3. I was thinking about if you have considered the possibility to go even to step 1 and step 2, if there are some technical issues, or I know it's just for simplicity, you go directly to step 3. And then second question was about sparsity problem, which is quite difficult to me to understand. How is it possible to have sparsity problem? And I saw that the welfare was a sum of the individual who got treated. So if you reduce the people, how is it possible that the welfare is reducing? Or the treatment effect has a negative effect? Or do we have a cost of the treatment inside this welfare function? That's all. Thank you very much in advance for your presentation.
Yeah, thank you for the questions that you raised that are of course very interesting. Okay, the problem of the arrow does not point on the other eligibility and unit selection. Is that I was focused on the agency this time, so on the idea of trying to provide the agency with so the policymaker, in other words, in his general definition, with a process of learning from the past, from other rounds of. But of course, you're right. There's in the agency choice, you may also have the unit eligibility, basically, and so in some sense, step 3 also contains step 2 and step 1. So that's the point. So I might yes, maybe modify a bit the scheme, but the idea is correct, that it is not something that just can modify not just the choice single variable, but the same possibly the same eligibility, if you want. You can make other individual eligible, for example, if you are going to change the rules. It's a problem of definition of the requirement of the policy, but you're right. The second point, the sparsity, yes, the sparsity is there, and you have singled out exactly the problem that we might have when, for example, all individuals have in the past had a negative effect. In this case, we have a 0 treated in the future, but it's meaningful, because the main idea is that you do not want an harmful policy. You would like just to run a policy that might have a positive effect on the society. For example, imagine a policy that is going to increase pollution instead of reduce pollution. You do not want to rerun a policy that just generates pollution or disease from pollution for everybody, you know. So in this case, the optimal policy would say stop running the policy. So it's the maximum sparsity possible, so nobody is going to be treated. But you're right, this is this may depend, and also on the initial number of the policy. Of course, in this case we had just 100 people, but in larger policies, probably the problem of sparsity may be less relevant. Even if I didn't speak about the levels, I spoke about the percentage of people treated. So 1%, 2% may be too low for a policy to be put into place. You're right, because, for example, the agency would like to, because we have enough money to spend, or for other. So the problem of the menu comes up again. The choice has to be done among different among a menu. That's the point. But you're right. This may happen that we have also 0 people to treat finally.
Okay. Yeah, it's your turn, Bianca.
Okay. I have a very simple question, Giovanni. If, for example, if we have a funding policy, I wish to understand if this kind of model is a 2 times or more times model, in the sense the policymaker found a first time the selected people, selected on the basis of their characters, good or bad, and only in the second period he is able to put the threshold, maximizing the treatment effect, and decide if go on with the funding or not. I have not understood if it is a sort of updating policy to evaluation. So the threshold, is it established in the second updating period or not?
Okay.
I am clear?
See, very clear. Yeah, understood. Okay, the point is more or less this one. You're right. Okay, suppose that you have a policy that has been already run. Okay, so in this case, we come up with 2 informations from this policy. The first is the level of impact or welfare, because in this case, impact and welfare is the same concept, right? But in the choice literature, they speak about the social choice theory, they speak about the welfare. In statistics, they speak about effect, but conceptually is the same. Okay, having said that, if you run a policy, if you consider an already run policy, you have 2 impacts that are there. The first is the impact that you see in the policy itself, and this is the one that has been achieved gross of, I would say, the selection process operated by the policymaker. So the selection process was there, and the effect of the policy is an effect that is that contains this effect induced by the selection. But possibly this selection might have been done not optimally. That's the point. And then you can come up with the randomized effect of the policy, which is the effect of the policy without the selection process. And this is another benchmark that we have. So we can calculate both. Okay, if we have, so this is for a policy that's already been run, okay? Now the idea is that, okay, this is the state of the art. Now let's try to see whether, according to what we have obtained from the past, whether we are able to generate another kind of selection, different possibly from the one we operated before, in order to increase the welfare we achieved. Suppose that the welfare we achieved was 10, and the randomized one was 5. The main idea is that, okay, I know that 5 is good, but I want to increase even more the indirect effect, the effect of selection, because the effect of selection is a good thing. It's something that we are looking for as policymakers, try to exactly picking the winner, for example, or aiding the poor, depending on the contest. But anyway, the main idea is that with this method, suppose that for some way you are able to come up with a new selection that bring the level of the indirect effect, of the effect of the policy, including also the selection, to 15. So you may say that you got a 5 point more. That's the main point.
Okay, thank you. So it is you learn from a past policy and you adopt the result to another one that is totally similar to the first one.
Yeah, yes, you were right when you said updating the selection process. You are going to select individuals differently with the aim of increasing the selection process, increasing the welfare, by cherry picking those that possibly weren't considered before.
Okay. The only problem is that you must have in the second time something exactly similar or equal to the first time, because otherwise, for this reason, I thought it was a 2 times policy, in the sense you can change, you can give the funding to only a portion of the selected in the first time people. For this reason, I thought it was only one policy where you adopt this 2 times evaluation.
Yes, I agree with you. We need to have a very strong similarity of policy over times. But for example, in the case of, for example, the funding of universities, or for example, in project funding, maybe I might be wrong, but maybe some of the, no, so let's for example of PRIN, of the PRIN or the FIRB, for FIRB in Italy, or other funding schemes. Some of them are similar over time, are not super different. Of course, to be honest, they are not a very good examples because they are quite, we have small numbers, just 100 universities, I don't know, or I don't know how many projects. But anyway, the main idea is that of rerunning exactly the selection of funding projects, for example, based on the past experience, but under the condition that the 2 policies are very similar, which is not granted.
Thank you.
A very good point, anyway. Thank you. Okay. I want to say that with Bianca, just because it is important to say, 3 or 4 years ago, we did a first paper about it with Bianca Poti, who was speaking before, which was exactly an idea a bit more theoretical about the scheme we have seen today, which is a bit more statistical. And it was about the idea of improving ex ante analysis, selection ex ante analysis based on past experience. So the idea was exactly this one, basically.
Okay, thank you. The next question is from by Luca Salvatici. Please, okay. Luca, switch on your microphone, if possible, also your camera.
Unfortunately, my camera is not okay. Working. So
microphone
is accept my voice, hopefully, if it works.
Okay.
I want to thank Giovanni because this was a very clear presentation and the point is very interesting. Following up on some previous comments, I think that policymakers can learn from experience, but also the private agents can learn from experience. So I imagine that some of the variables that are used by the policymakers to improve the selection could be under the control of the agents. So they could adjust them before the next election. And this adjustment in some cases could be something that the policymakers like. In other cases, it could be something that you don't like. So there is a kind of a moral hazard, sort of a strategic game interaction, which I think could be another interesting extension of your work. Thanks.
Thank you, Luca. It was a very good point. To be honest, I didn't think about it when I was writing this small paper. Yes, you're right. Individual. So what is the main idea? Just to rephrase what you said, was completely correct. And the main idea is that we are exactly, not only, we are looking for a mapping between the axis and the treatment, but there is another big mapping, which is the X from the outcome. So we are exactly running this exercise by assuming that individual will reply to the axis in terms of the outcome, not in terms of the treatment, because the treatment is on the end of the agency, but the individual will react to their characteristics in case where they were treated or even untreated, of course, in the same way. So yes, this is exactly a good point. So the idea that that individual can change some way their behavior, so modifying this mapping between the X's and the Y can be a problem, of course. Suppose, for example, the geo, myself, I react to my X's in terms of earnings, so for example, my age has an effect on the future earnings I will get. Suppose that this age, or age is not a very good example because it's a bit exogenous, but suppose that is my, I don't know, my position, my I don't know, something else, my education, for example, and my future earnings. So the main idea is that given my characteristics, I will respond in terms of earning in the future in this way, and this way, okay? So in the second run of the policy, this mapping may change. Possibly even people or myself having the same, exactly same characteristics may respond differently to the why for some reason. Possibly because they have learned themselves something, or for some other reason. So you're right, we are working on a condition in which we have to be very careful in concluding that the estimates are perfectly in line with what is really going on. However, the only positive things that I can think about it is that when we have several runs of the policy, so we are in some sense analyzing the behavior of individual over time, and so it lends a lot of robustness to the possible analysis of the mapping of the axis on the y. Because in this case, we know that people more or less in the last 10 years have responded this way and this way and this way. So probably even in the future, they will respond similarly. The problem is when we have a few, for example, a policy that is very unique and just run once any, let's say, 3 or 4 or 5 or even 10 years. In this case, it's pretty impossible to, but this is our general problem. It's the problem of having a sample which is too much spread over time, so that the relationships are not the same over time. No, because they are going to change. There is a sort of no ergodicity of the model. So it means that the mapping are completely wrong. So you're right, but I think that in some cases, maybe this might be handled some way. Okay.
Okay, thank you. We have a last question by Mario Nosvelli. Please, Mario.
Okay. Thanks a lot, Giovanni. I appreciate very much your effort to operationalize, as you said. I think old concept, because I remember that threshold has been used by in labor economics until 70s in the idea of finding work in a job search, and they try to work on that reasoning in terms of thresholds, of acceptations, and so on. But you try to operationalize that and to make available an instrument that could be useful for policymakers, and I appreciate that. I appreciate very much. I have a couple of questions about that. The first is about how you showed results in the slides, where you showed the different combination, where you choose the solution with the highest, I think, average welfare. Yeah, this one. Trying to show how this different combination can be used, and this could be a flexible way out, in the sense that you can choose whatever solution in base of your, of your options. But on the other way, it could be quite empirical and quite open to solutions that are not really optimal. I don't know if you get what I mean on this. I mean, you have different options. You can choose any one of that. So it's quite flexible how to pick up, as you say, the cherry picking here, but also on the other side, optimality is quite open as a concept here. And the second question is about the basis, the clue of the model that is based on past results, and this can be a problem for me in the last years. For example, if you should choose a database like that of Lalonde is very famous. Now I don't know if it could be reliable, in the sense that what has been in the past is been changing very much. So maybe you can't rely on what have been done because it's not more useful for the future. Now, for example, with the pandemic, what has been done in the labor market maybe is not useful for next years. Education, for example, you showed that education up to 15 and then is not reliable. Maybe that function is going to change. So the question is, how can you rely on the past if the past is not more, I mean, useful for your decisions, considering that the main constraints for policymakers is information, as you know. So this couple of questions are crucial for me.
Yeah, yes, Mario, thank you very much for your questions that are really appreciated, because even in this case, you raised a couple of points that are extremely important. Okay, the first is about the maximization. Okay, anytime, yes. Anytime we have the very problem is that all of these graphs here comes from a maximization. Okay, so they are the best possible selection given the data you have, basically, right? However, what we are going to change here is that we are going to change the threshold for education, because education had this monotonicity. So the best of the best would be this one. But the best of the best will generate a situation in which you have to try to treat just one person. So it is quite a strange policy in which you treat just one. And of course, it does not make sense. So this monotonicity, in other words, this inability to find an optimal, an inner optimal, provide us with we find a constrained optimal. For example, I might choose one of these according to the budget I have, so that I may cover the budget, for example, completely. Or I would like that something's going to be just partially covered or whatever. Okay, so you can introduce a third level criterion, like the budget, for example, in order to select optimally this. Of course, they are all local optima, in the sense that no one is the best in an absolute terms. It depends on the context. It depends on, but the policymaker can introduce another one criterion, and then finally select the one that is best, like in a, I would say, as a local optimum. And so this makes sense. The second point is very important, and I think that it was in line with the point raised by both Luca and Bianca, was about the fact that the learnings depends on the past. This is exactly the very limitation we have also in machine learning. Machine learning is all about learning from the past. And even in this case, we have the same problem. We learn from the past. We do not learn from, let's say, something that we don't observe before. So you're right. If you comes from a non-ergodic reality, so a reality in which the present is completely different from the past, and so the mapping between the x's and the y, it's really uncertain. So I do not know whether one injection of €1 in investment is going to generate certain euros as earnings, because now the pandemic has generated structural break, so that we don't know. Yes, you're right. If it is true, and the reality is unfortunately not ergodic, we have to conclude that these methods will be very biased. And so probably we think that, let's say this is 2.9, but in the reality, it is just a 2. And this is possible, of course. This is absolutely correct. My point is, again, that as long as we are going to increase the information about policies, and we have a larger number of data and information, structured information about policy and blah, 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 I think that the learning process may be even quite good. So even in the time of big data, high frequency data, and blah blah, I would say is the same logic that this is a classification problem, right? And that wants to optimize a given criterion. Imagine what Facebook does. Facebook is going to select all in order to send advertisement to them in order to maximize the profits. So if they have all this information about you and they are generated mapping about the selection of individuals according to the largest profits possible, it is clear that they are also learning about the change introduced by the pandemic. Why? Because they recognize that some of this selection process was no longer good. For example, it's useless now to send the people advertisement by restaurants if they cannot go to the restaurants. It's much better to send them advertisement about, let's say, for example, takeaway food or something like that. So the learning process is continuous. Of course, you're right. In terms of policy, it's a bit more complicated because we don't have such amount of high frequency data or that provide us with a sort of nowcasting, I would say. So it is a bit more complicated, and I agree with you.
Excuse me, Giovanni, you did a starter routine open on this model or not yet?
Not yet, unfortunately.
Okay.
Not yet, but to be honest, we used these. I don't know whether Alessandra is online, but we applied this method and we're going to publish, we hope, with the IFAD project, International Fund of Agricultural Development. We developed exactly this method to singling out the optimal treatment in policy in developing countries so we did it. I promise that I'm going to provide the people with for free with a data routine for running this, at least with the 2 criteria, because the problem is to generalize this to more than 2 criteria. But however, I think that even with 2 criteria we can. So with 2 criteria, I mean 2 variables like education and age. And so even in this case, it might be very useful because generally policies have not more than 2-3 criteria. It's very rare to find a policy that is going to select according to 10 criteria. That is me a bit even impossible to manage for a policymaker. But maybe 2 is not too much. Maybe 3 or 4 might be better. But this is something that I have to come up with if I have time. But yes, of course, I will find time to do it.
We'll follow your work. Thank you.
Thank you, Mario. Thank you.
Okay, I think that we are at the end, and I want to thank Giovanni for this interesting seminar. I want to thank all the audience for the question, for the attention, for the debate. That was really interesting. And I want to invite all of you to the next seminar of our institute that will be on the 6th of May, and that will be held by Riccardo Fini from the University of Bologna. That will be on the knowledge transfer from university to the private sector. I want also to thank Serena Fabrizio, that is helping me in the organization of this seminar, and that is helping me on the technical part of the seminar. And I want just to remember that in a few days will be available the registration of this seminar. Okay, thank you to all of you.
Thank you, Lucio.
See you to the next seminar.
Thank you, Serena.
Thank you.
Okay.
Thank you.
Bye-bye.
Bye.
Bye.
Have a good lunch, everybody. Bye. Thank you again. Bye-bye.
Bye.